What's going on, guys? Let's look at this problem right here. Here this question is asking a current sheet with K is equal to 10 AX amperes per meter lies in free space in the Z is equal to 2 meter plane. A filamentary conductor on the x-axis carries a current of 2.5 ampere in the AX direction. Determine the force per unit length on the conductor. So here the question is asking us to find out the force per unit length. Okay. And if you look at the question here, we are interested in finding the force per unit length. Now let's look at the equation that's related to force and the length. If you look at the equations, this is more suitable here. F is equal to I times L cross B. Now here we are interested in finding F over L. So we don't need to know the L, but we have to know what is I and what is B. I is given in the question 2.5 ampere, but we don't have the B given, right? B is the magnetic field. Now to find out the magnetic field, we can use this equation. B is equal to mu naught H, right? Mu naught is the constant, so we know that that's a permeability constant. Now H value is the magnetic field intensity. We don't have that one provided. Since we have the current density, free current density provided right here, we can calculate this one. To calculate this one, what we have to do, we have to use this equation. H is equal to half K cross AN, right? K is the free current density and AN is the vector, unit vector normal to the interface. So we have these two available, so we can calculate this one. Now we can directly plug this one in this equation and calculate all together. Okay. Now mu naught time, instead of H, I plug this equation, that is half K cross AN. Now let's go ahead and plug the values. Mu naught half K is given, that is 10 AX. 10 AX cross AN. The normal is negative Z direction, so negative AZ. And if we do that, that's going to give us 5 mu naught AX cross negative AZ. That's going to give us AY. So this is our magnetic field. Now we have the magnetic field, so we can calculate force per unit length. Now let's go ahead and plug it in this equation. Okay, here let's continue here. So F is equal to I, instead of L, here they have mentioned a filamentary conductor on the x-axis. So instead of L, we can place L AX direction, in the x direction. Cross, we found out magnetic field, that is 5 mu naught AY. 5 mu naught AY. Okay. Now we have to rearrange this one in terms of F over L. If we do that and do the cross product, we are going to get 5 mu naught IAZ. Okay. So this is going to be the answer, and we can just go ahead and plug the values. 5 times, what is the permeability constant? That is 4 times 10 to the power minus 7. 4 times 10 to the power minus 7, and I is 2.5. and if you calculate this one, and all of them are in the Z direction, and if you calculate this one, you're going to get 15.71 times 10 to the power minus 6 in the Z direction, Newton per meter. So we can say 15.71 micro, 10 to the power minus 6 is micro Newton per meter. And that's going to be our final answer. And that's how we do this kind of problems. I hope this helps. Thanks for watching.